Have you ever wondered if playing video games could make you smarter than a PhD? It sounds like a clickbait question, right? But what if I told you that in 2016, thousands of everyday gamers, people just like you and me, stumbled upon the solution to a complex math problem that had baffled top mathematicians for over 20 years? This isn't a science fiction story. This is the incredible true story of how a beautiful, enigmatic puzzle game called The Witness accidentally became a revolutionary tool for mathematical research. Forget everything you think you know about gaming. Today we're diving into how a world of colorful lines and intricate grids led to a breakthrough in the field of combinatorics, proving that sometimes the most profound discoveries are made not in a lab but through the power of play. So, what was this impossible problem that had the academic world scratching their heads for 2 decades? It all comes down to something called polyomino tiling. Now, that sounds complicated, but the basic idea is actually something you've probably encountered before. Think of Tetris. You have different shapes, and you're trying to fit them together without any gaps. Polyomino tiling is the mathematical version of that. A polyomino is a shape made by connecting equal-sized squares edge to edge. For small sets of simple shapes, this is easy enough to figure out. You can just try a few combinations. But as the number of shapes increases and their complexity grows, the number of possible arrangements explodes into the billions, trillions, and beyond. It becomes computationally impossible for even supercomputers to check every single possibility. Mathematicians weren't just trying to solve one specific puzzle. They were trying to find a universal rule, a formula that could predict whether any given set of polyominoes could tile a grid. For 20 years, they published papers, developed theories, and ran complex algorithms. They were searching for a kind of no-batona, quick way to identify sets of shapes that were impossible to tile, so they wouldn't have to waste time trying. They made progress, identifying certain conditions that made tiling impossible. They had a list of criteria, a set of rules that said, if your shapes have these properties, don't even bother trying to fit them together. These rules were the bedrock of their understanding. They believed their list was complete. But they were about to be proven wrong by a completely unexpected group of people. Enter Jonathan Blow, an indie game developer famous for his critically acclaimed game Braid. In 2016, he released his long-awaited follow-up, The Witness. On the surface, it's a game where you explore a mysterious, beautiful island and solve line-drawing puzzles on panels scattered throughout the environment. There's no dialogue, no instructions. The game teaches you its rules wordlessly, through the puzzles themselves. Tetris-like shapes that you have to draw within the puzzle grid. These are the polyominoes we were just talking about. The game had over 500 of these puzzles, each one meticulously designed, each one a unique, logical challenge. Players weren't thinking about advanced mathematics. They were just trying to get to the next area, to unlock the next secret of the island. They were driven by curiosity and the satisfying click of a puzzle solved. They were using intuition, trial and error, and spatial reasoning. While mathematicians had their formal proofs and academic papers, players had persistenze. Persistenze. This is where things get truly amazing. A specific type of puzzle in The Witness presented players with a grid and a set of polyomino shapes. The goal was to draw a line that partitioned the grid into regions that perfectly matched those shapes. Essentially, it was a polyomino tiling problem, disguised as a fun puzzle. One particularly notorious puzzle, found in the town area of the game, was a 4x4 grid. With a few tricky it seemed impossible. Players spent hours, even days, staring at this single panel. They posted on forums, on Reddit, sharing their failed attempts. They drew diagrams. They argued about strategies. And then, someone found it. A solution, a path that correctly partitioned the grid. But here's the twist. According to the established mathematical rules, that solution shouldn't have existed. The set of shapes in that puzzle had properties that, according to a 1996 paper by a group of mathematicians, made it impossible to tile. The gamers, without knowing any of the formal math, had just broken a 20-year-old mathematical conjecture. At first, nobody really noticed the significance. To the players, it was just a really, really hard puzzle. They posted screenshots of their solutions as trophies of their intellectual victory. But eventually, these screenshots started to circulate outside of the gaming community. A computer scientist and puzzle enthusiast named Nicholas Betts saw one of these solutions. He was familiar with the mathematical literature on tiling problems. He recognized the shapes and knew that what he was looking at was, according to the experts, impossible. He was stunned. He and a group of other mathematicians started digging deeper. They realized that the game, The Witness, was a massive, unintentional experiment in every solved puzzle in the game was a data point. The game had 523 of these specific puzzles. The mathematicians had their handful of theoretical examples and papers. The players had 523 practical, proven solutions. A collaboration was born, one that bridged the gap between the academic ivory tower and the glow of a computer screen. It was crowdsourced mathematical research on an unprecedented scale. The mathematicians reached out to the game's community and its creator. They began systematically analyzing the game's puzzles. They discovered that not just one, but two of the game's puzzles served as counterexamples to the long-standing mathematical belief. The player's intuitive, brute force approach had revealed a flaw in the formal logic that had been accepted for 2 decades. The players weren't constrained by what they thought was possible. They just kept trying until something worked. They were thinking outside the box because they didn't even know the box existed. This led to a new research paper, co-authored by mathematicians and a puzzle analyst from the gaming community. The paper, titled The Witness Puzzles and the Garden of Forking Paths, explicitly cited the video game as the source of its breakthrough. It refined the old rules and presented a more accurate understanding of polyomino tiling. Game designer Jonathan Blow hadn't set out to do this. He later explained that he wasn't a tiling expert. He simply designed the puzzles based on what felt right, what was aesthetically pleasing and logically interesting. He had unwittingly created what he called a digital intuition pump. The game's interface allowed players to test hypotheses and explore spatial relationships far more rapidly and intuitively than a mathematician could with a pen and paper. The players' collective spatial reasoning had found what years of formal logic had missed. So, what does this all mean for the future? This story is more than just a quirky piece of trivia. It represents a paradigm shift in how we can approach problems. It shows that complex scientific and mathematical challenges aren't just for experts in white lab coats. Games can be powerful tools for discovery. We're already seeing this in other fields. Take protein folding, for example. The game Folded allows players to manipulate virtual protein structures. Players have solved problems in minutes that had stumped scientists for years, contributing to research for diseases like HIV and Alzheimer's. Their spatial intuition about how shapes should fit together consistently outperforms computer algorithms. We can imagine games designed to model climate change scenarios, allowing millions of people to experiment with different policies and see the outcomes. Or games that help design more efficient city layouts or logistics networks. What other monumental problems are out there, just waiting for the right game to be invented to solve them? Maybe the next great scientific breakthrough won't come from a university, but from a gamer, late at night, just trying to get to the next level. Thanks for watching. If you enjoyed this story, don't forget to like, subscribe, and hit that notification bell for more videos. Exploring the fascinating intersection of technology and human ingenuity.